ahead and jump right into more of me talking. We are going to talk about ORMs. I keep telling you about ORMs. We are going to talk about them, and right now I'm blanking. Object relation management. I'm pretty sure that's what it's about because that's the problem it solves. Acronyms. There are too many of them, but I'll look at that and think of it. Anyway, we're going to start with acid. I keep talking about acid. You're like, hey, what is this acid? It sounds like fun and pain. And it is. So it's a set of properties that pertains to database transactions. I talked to you guys, especially during schema design, about the importance of SQL in banks, especially for the consistency aspect. They are so consistent, and because they focus on consistency and not availability, they focus on transactions and making sure things are consistent. Like, what does it mean to be consistent? Atomicity, consistency, isolation, durability is what we're going to talk about. And when I say transaction, that is a single operation, but it can contain like a couple things. The easiest example for me always is just like crediting one count and debiting another. Those are two things, one transaction. Two things, one transaction. So I always have a fun and silly, everybody is going to visualize, what does acid mean? I need two people to come up, and I'm going to give you fake paper money because I usually have cards, and those have been misplaced. So now I need the two volunteers. Okay, we got Liz, we got Susanna. But Luisa's on deck because for the third one I need three people, so this is going to be perfect. Okay, you get 3 paper monies. I'll give you both 4 paper monies. It's an equal kind of day. We need some equality. So we have two. It doesn't matter. You can stand anywhere. I think everyone can see you. We have 2 people. When we're talking about atomicity, I can say it when I'm not in front of people, and when I'm in front of people, my tongue just stops. All or nothing. So in this situation, Liz is going to die, and it's going to be sad. Susanna, you are trying to Venmo her money. So you're like, what's happening in the database is we are trying to debit your account too. So start debiting her too. Okay, she dies. Oh, okay, you can't give her 2. So your account has already been debited, though. Her account hasn't been credited because she's dead. All or nothing. We have to roll back. You get to keep your $2. We give it back to you. The bank doesn't get to keep it because that's mean. Well, now we understand all or nothing. And Liz didn't really have to die. Consistency. It brings us to a valid state. This time, Liz is going to try to pay Susanna twice. Let's do it, and this can kind of get us into isolation as well. So she's going to start by paying 2 fake monies to Susanna. She pays 2 fake monies to Susanna. This is wonderful. You probably should go through me. So it was like debited from you, credited, just for visual, you know, making it, yeah. Great. This is great. And now you try to pay 3 monies. That's not a valid state. I'm so sorry. This is inconsistent. Please go home. So then we have, give her 2 monies back. Then we have.
So why was it inconsistent? Because she didn't have enough?
Yeah, because consistency, in this terms, when I say consistency, there are 2 different ways to look at consistency. Consistency in terms of CAP theorem, which we're going to talk about in a second, which is consistency of all database materials, and then consistency inside of ACID, which is about being consistent in the database itself, which goes with all of the constraints made on the database, which is no, for banks for money, are hopeful thoughts. So I guess some banks let you go into the negative. No negative integers, basically. Decimals, floats, whatever it is. No negatives. So that is a constraint on the state, and we tried to not have a valid state, and it's like, okay, we took your money. Nope, we can't take your money. That's an invalid transaction you're trying to do, and rolls it back. Then when we get to isolation, I feel like a good one for this might be, so it's concurrent execution that mirrors serial execution. Concurrent, what does that mean? Like, next to each other. Like, so Louisa, you come up now, and you're going to get some fake monies too. I feel like this is going to be the best way to see concurrent, like 2 things happening at the same time. you've got. I'm wasting trees, and I feel a little bit bad about this, but I'll keep them. I'll keep them for later. 2 and only 2. So Louisa also has 4 monies. And serial execution, serial means one after the other. And what we're trying to prevent here is any sort of deadlock happening. So concurrent, let's say at the same time, both of them try to pay Liz $2. And it comes in, oh my gosh, at exactly the same time, but I have to make them happen serially. Ooh. And if something had happened where in between, give me a Louisa's back. It's like I made them happen serially. So I started with Susanna's. This is Louisa's monies in my hand. You can't tell, but I'm telling you they are. And Liz dies. She goes offline. All her databases are dead. We can't ever reach her. I know, I'm really mean to her today. Does that mean that all of the exchanges need to go back because they happen at the same time? No, only Louisa's need to go back. Susanna's money is going to stay with Liz because that is a separate transaction that has already been accomplished. Even though they happen at the same time, and as like little database me, they're like all right here in the same pool. So, isolation. And then durability is if right now all 3 of them fell down and went offline, yeah, Westworld style, they just were powered off. When they were powered back on, they should still have that information. Persistent. I mean, I think durability is the easiest of these, hopefully, to understand, where even without power, you persist. That was it. Thank you for your wonderful acting skills. So you're like, Kate, what is this cap theorem thing you're talking about? Well, good thing it's my next slide. Cap theorem, consistency. This is all clients seeing the same data. So not valid states, but all clients seeing and having access to the same data all the time. And availability means each client can always read or write. And these two are like, they sound like they go great together. They go terrible together. They're always in opposition to one another. And I've got a great like party analogy to help you understand why. Partition tolerance is when a system works even if the network splits. That can mean us partitioning our database and our like actual nodes in the network. It can also mean failure. Like if part of our network fails, if part of our database fails, that is being partition tolerant. You like implicitly have to have some bit of partition tolerance for the fact that you have to plan that the worst could happen where all of your servers go down, half of your servers go down, all the servers on the East Coast but not the West Coast go down. Now you're partitioned even if you don't want to be. A lot of people see this as a pick two. Like often you hear, I've heard in college, like you get to sleep, have a social life, or good grades, and then you just pick 2. And just like it's more complex in reality than you just pick 2, this is also more complex in reality. Some people even feel like the idea of having consistency, availability, and partition tolerance isn't a really good theorem anymore because partition tolerance, in a sense, if we're talking about network failure, is talking about availability. So theorems are theorems and everything's always changing. And the only time that I think that you will need to know anything about acid anything, and the opposite of acid is, they say base, and all of this is very like kitschy, like they're trying to come up with the right acronym that will stick and be used. I told you about NoSQL databases. NoSQL databases are base databases. And not nobody, but that didn't catch on quite as much as acid, the terminology there. But if you want to do a tech talk on databases, those are 2 things that you could think about. And if you're going to start interviewing in places that are going to be really on the back end and heavy, potentially talking with databases, looking at cap theorem, acid, base, and then just like different types of databases in that realm would be a good idea. But I would say for the most part, conversation with people and interviews are when this is going to really come up, other than the fact of knowing that SQL focuses on consistency above all else. So tell me about CAP Theorem. Say we're at this awesome festival and all of us are there together. Unfortunately, because so many people are there, none of our cell phones are working. So none of our cell phones are working, and 5 people got to go to the bathroom. The other 19 of us, however many of us there are, 20 of us, because I'm here too, are still at the concert, what is it called, stage, are still at the stage. By having 5 people move somewhere else, we are immediately being partition tolerant. Like, we are separating and being in 2 different places. Now the question is, if the people who went to the bathroom make a decision to go get drinks, or the people at the stage make a decision to go, like they want to go get a corn dog. I love corn dogs. We have to then decide on consistency or availability. I have this in just like 2 concise things, right? Do you stay consistent wherever, right, yeah. So by choosing to not just go to the bathroom and come back, by choosing to not wait for everyone from the bathroom to come back and go somewhere else, I'm making myself available. At any time, I can be available. I can write to the database, do something else, go get my corn dog, go get a drink. I'm always available. I'm focusing always on availability. Or like SQL, you can focus on consistency, where above all else, you consider consistency the most important, where you will wait here until everyone has come back and you know that everyone is at the same state together. You're like, you've come back. That was a really long time you spent writing to the file system. But I'm glad that we got that over with, and we can now continue with the work. So by insisting on consistency, we don't always have availability. Does that make sense? And that's like the big takeaway from SQL and the CAP theorem, is that SQL focuses on consistency and thus can be hampered by not always being available. Availability is what it will give up to focus on consistency. And other databases find it more important to be available. I've worked with CouchDB, which is amazing for its use case, which is always being available. And then when everyone gets together, when we all get like Wi-Fi again and we can text, then it syncs back up. But you will have like potentially conflicting information, and then there needs to be some system or human to figure that out. So you're not always consistent, and that can cause errors. But you are always available, which could be bigger than being consistent, depending on your use case for your business. We are teaching SQL, so we are now knowing that it's consistency that we focus on. But maybe later in your senior phase, you'll look at something like that, or Mongo, or Firebase, something that is a little bit different than just SQL. Now we're finally getting to the ORM portion of this. Sequelize is what it's called. I've been talking about it a little bit. All this is an abstraction over PG that you've already worked with. You wrote SQL queries, and now you will do that no more unless you enjoyed it and do it in your leisure. Sequelize is an object relational mapper. Mapper, not manager. Right, that's ORM. So I told you, and I think maybe you intuitively also realize that SQL holds things in tables. We have relations, attributes, instances. Attributes is similar to an object, a property, or something, but the way it's shaped does not directly correlate to our objects. And the way PG gives stuff back to us is, thank God, not just like a string of all of this stuff, but in an array. And Sequelize gives it to us in an even better format. And that is why we use Sequelize. It makes our life even easier. And it prevents us from having to create tables and queries in quite the same way. It's much more like all the other code you write in JavaScript. It's going to look like JavaScript code, even though we're doing something that underneath is create table so-and-so with all of these schema attributes. So it has access to the SQL databases, and we can do the schema modeling and validation all from our code, and not have to do it in a string, which can be very error-prone. Which, I mean, sometimes you'll still have errors. You're going to have errors in everything you do. But That's fine. Data casting converts SQL types to JavaScript types, and PG kind of already did that a little bit for us. It really helps a lot with query building. You can just do .find, and it will find everything. You do .find bracket where, and that's in, and I'm going to do a quick coding thing at the end of this. Yeah. Wow, yeah, I'm behind. Hooks are codes that run pre and post, save, delete, update, so we can have like kind of callbacks queued, you know, that will run only when this action happens. Except they aren't callbacks, they're just like methods on something. So they kind of are like event handlers. So they kind of are callbacks and make you feel like event handlers. We have class and instance methods. A class is going to be the entire table. An instance is a row. And Sequelize has very powerful classes and instances. And then we have getter, setters, and virtual fields. These will probably be confusing for a little while. You won't use them often. But a getter and a virtual field are the things that are kind of similar. And a getter is if I have something that's just one string separated by commas, and I know that's how it always is. Every time I get it, though, I want it to be an array, each index being the item separated by the comma. I could do a getter that says every time you pull from here, don't give me a string, give me an array, do it like this. And it will do that every single time I query anything from the database. And setters are the opposite. They actually store it in the database. So getters and virtual fields are not stored in the database, whereas a setter is stored in the database. What we frequently see for setter is if you type your entire name, and when you start to save it into the database, you can have a function that says, for this, take first name, and like take this, separate by the space, first name, last name, and then you have two different fields, first name and last name. So programmatically, that would be like, you have the name, and for this field, have a set, for the first name field, have a set that would split on a space and take the first one, which is like a slice or something. That's kind of a complicated example. But you will work through some stuff like this. But let's talk more about Postgres versus Sequelize. Postgres, we had our tables and our rows, literally equivalent to Sequelize models and instances. Models are classes. So with a Sequelize model, it will directly correlate to a table if you save it as a table, but you define it as a model, and you define the schema in Sequelize, and it does not necessarily have to be in your database. But if you sync it and save it to your database, then it will directly correlate. Same with instances. You can create an instance, but it's not in your database until you save it in your database. But when you get a row out, it will be an instance. When you get a table out of your database, if you're just looking at a database and trying to find a table, it will come out as a model. And I think that'll make more sense when we do some coding. These are some of the things that you can do. Make a model, just like you would make a table. Extend them with hooks and methods, something to do every time on the class or on an instance, or available to a class, to every class or every instance. Virtuals, like we talked about a little bit, connecting from Sequelize to the database to make an actual table in the actual SQL database, and use that to create, find, update, delete, do everything to instances. Let's look at some code. Let's make some code. Did I write anything in here yet? No. I just made this at the end of that. So, input. What did I write? That did not work. Init-y. Is that what I wrote? No, must not have been. First things first, my elephant is not here. Postgres is not running. Let's have that happen. Now Postgres is running. Now I can start to get to it. For Sequelize, we need to install, off the top of my head, install -save Sequelize. And I think it does not automatically do PG, but we will see, and it'll just tell me what I need. Let's also touch db.js or something. And that feels like a good place to start. So let's start coding in here. And the first thing I'm going to do is look at Sequelize. Required in is how I look at it, Sequelize, but lowercase s Sequelize. And let's look at our package.json, make sure it's there. Yeah, lowercase s Sequelize. Okay. The way to connect here is pretty similar to PG. We type new, but we don't have anything to do with the client. Now we can just type new Sequelize. And this time, it is the similar protocol, so the Postgres protocol, where I'm going, the localhost, my port, this one has a port. The last one had an implicit port because it was PG. I don't know why it had an implicit port. But on with Sequelize, you have to specify the port. And with people who have non-Macs, you may run into problems where you need to write your username and password in the connection string. But they have good documentation on that in Sequelize docs. Sequelize docs overall are very difficult to search. But if you just go to like starting with Sequelize, it has a great thing you can copy and paste. Just because I know we have a number of non-Mac users. Let's see if I have, let's see what databases I have. So I want to do WikiStack, but it doesn't necessarily mean I have it. WikiStack, okay, there is a WikiStack. So we're going to do WikiStack because that's what kind of makes sense. Let me empty everything out of it. Here. Sweet. WikiStack, what you're going to make today is like a fake Wikipedia. You made a fake Twitter, now you're going to make a tiny little fake Wikipedia. How do we define a model? A model is like a table. You kind of saw that there's going to be a user. We're going to start with just doing user. DB, so the database that we just made, dot define, oopsies, but with a dot, dot define, and then in lowercase, the name of the table. With just this, it will, in post-to-co, you will see that it is pluralized. That's what happens. Do not be like, oh my gosh, whatever, like it's all messed up. It does pluralize it, but I would say do lowercase, because if you do an uppercase U, then you can start running into issues with your casing, and it being like very strict on that. The next two things it takes are two objects. The first object is table schema, basically, like the attributes of attributes, but with S. The next one is methods. These can be the class methods, instance methods, hooks, all those things. Those will be in this next, the last, like options object. So let's start by just defining something that takes a name. And now for type. You did do like int, varchar, all of these things. Now it's a little bit easier, but you have to know what is available. Sequelize does have data types. If you Googling Sequelize data types is going to be the best way to probably search their docs at this moment. You can use their internal search, but it can be difficult, just so everyone knows. String, all in caps, which is important. And I think we, in the end, are going to have a picture URL for them, which will be a Sequelize. We'll do a string right now. It'll be like a URL pointing to a picture, like a place kitten or something. And let's just start with that and see what happens. Let's start by sync. This is how we create the database in actual Postgres, saying sync. So doing .sync will actually create that table, not the database. I just said database, but that table. You can also do, which might be helpful for you later on, db.sync, which will sync your entire database with all of the schemas you have like designated in here. But we're not going to look at db.sync because that's super big right now. Let's start with this and just see what happens. If I write No, db.js. PG. Okay, yeah. Great. And you can turn the logging off, but I kind of like it. It's telling you what it is executing at each step. It's executing this like literal SQL. The sync did create table if not exists users. And now let's go to our posticle real quick and see if I refresh. I have a users table, and it has an ID. It created all on its own. We don't have to do anything with ID. It's going to be serial, auto-incrementing. You don't have to even worry about making, inserting, updating anything with ID. It has a name, and it has a picture URL, and then it also has created and updated at. Those are also done by Sequelize that you don't have to worry about. And I honestly don't usually use them. But if you do, you do. I don't know. There is another, let's just do .then. This is a promise. Sync is a promise. So we can then have a .then. And this .then is going to build a person. We will make a person. We'll start with just building a person. So I have person. This person is me, and it's user.build. And by using the keyword build, I am creating an instance in my JavaScript, in my Sequelize. Build does not ever save to the database. .save saves to the database. So let's make a person, name Reina, picture URL. Let's do GP, what is it? It's like, I know Phil Murray off the top of my head. I can't remember how the place kitten one goes. And I don't know, 100, 100. To then save it, I would have person. Each instance has a .save method. The .save method is asynchronous because it's talking to the database. So that is something I would want, would want to return. .then, and once I get down here, I should see that something is actually added. Look, my console log done. So now if I refresh this, I see Reina, and she has a Phil Murray picture. How awesome. Let's do it again and see what happens. I have 2 Reinas. I don't want 2 Reinas. I want to have all this test data go away every time I run the database again. How do I do that? There's an option that you can put inside of sync, which is called force true. And if I do force true, and I refresh postico, there's 1 Reina. So force true truncates whatever is there, and then I think it truncates. It might like delete the whole table and rebuild. One or the other, which are very different. But I think it's truncating it. But same in the end, where all of your data that was there before is gone, and your table should be built based on the schema you defined here. So here is a table schema. db.define only defines it in Sequelize in our JavaScript. .sync is what pushes it and saves it to our actual Postgres database. .build only defines it inside of our JavaScript. .save, which is also asynchronous, is what pushes it to our database. So you start noticing anything that is pushing, touching, talking to the database is asynchronous. It's going to be a promise. Everything that is not is synchronous, and .build is one of those. And knowing which is which, you can console log, look at documentation, and a lot of like muscle memory at the end of the day. So instead of doing build and save, there is another option. And that option is to do something on the table itself. So we have the user table, and I can do a .create. And if I do a .create, I send in an object which looks just the same, Meredith. And your picture URL is going to be the same. You will look like almost Twinkies. Return, so then in our next .then, we should have I'm not going to do anything with it, so it doesn't really matter, but I guess I could. Better idea. Let's do a promise.all and look at them both. Promise.all. Person.save, and then user.create. And then this should be array of created peoples, and let's look at them. Here. Did I save this? Yes. Cool. Woo! So I get an array of instances. It says capital I instance because it is a Sequelize instance. That is an object that is more powerful than just an instance, a row, a tuple in the database. It is a Sequelize instance, which has its own methods. We just saw .save. .save is a method on an instance. You can make your own methods on all instances. You can do the same for tables. We see that it has data values, but if you just do something like 0.name, that is how you can get to the .name instead of having to do array 0.datavalues.name. It's actually just .name because it's the data values it's the value of and how that works. And just to show you that both of them are there, here's the second instance, ID of 2, Meredith. And if we go back and just log, we see we get the .name, which is Raina. And we didn't have to do anything with the data values. That's the biggest thing I see people start doing is they are like array of created people .data values .something. You don't need to do anything with .data values. You can just go .name, and then you have access to it. To show you another way of looking at the same thing, user.find. Find all. Or is it just find? A lot of ORMs are similar. I'm going to go with .find and assume that that's the one. Let's see. If not, it's find all. .find is a method that is on a class. User is, because of doing db.define, user is literally a Sequelize model. And that is some object with a lot of methods and properties on it. One of the methods is .find. Another method is .create. So we'll walk you through like the important methods to get to know at the get-go. And this then, it should be all users. Let's see. If we console.log all users. Yeah, so it's find. And we'll see Raina and I only saw it there. No, I only saw Raina. How interesting. So giving them back one at a time. No, that doesn't make sense. It is an instance. Find. Find all. Oop. Okay, find just finds one, and you only get one instance back, which is why it was just Raina. And if I did find all, I got Meredith as well. And these are previous data values. It's like a versioning thing similar to get. Not much you need to look at other than that in here, I would think. Right. So you saw me just use one find. There's also find one, find by ID, find all. Find all returns an array. Find just returned a single instance, the first one it finds. And to do a query where what? Name equals Raina, something like that, or is that name Raina? Let's see how the syntax goes. Nope. Yep. Yeah. So I found all, so we still are getting an array back because I did find all, and this time I only get Raina. No Meredith. Yeah.
And you're using this
Yeah, this is Sequelize syntax. And you saw me just kind of forget it for a second, but it's generally in my fingers somewhere. And looking through the docs is what's going to be most helpful for you today. And also playing around and console logging everything that you have a question about. So that's like a big overview of Sequelize. You feel like it's not connecting to the database in any different way. Oh, that's what I have left. If we want to walk through exactly what's happening. I put some slides in so that you can know the code in the slides in case, I don't know, you don't want to look at the code. Now, we added one thing. We had everything up until here, and now we're adding an ORM, Sequelize. It has schemas of models which hold instances, and those go straight to PG, which is why I had to install PG. And PG itself is the one that can talk to the database, which the database is the one that can talk. PostgreSQL is our database, this one. And the database is the one that can talk to our file system. So we are in JavaScript talking to Sequelize in a more JavaScript type way than PG, which is nice. Sequelize talks to PG, PG talks to PostgreSQL, PostgreSQL talks to the file system, and that is what my next slides are. I'll walk through. What happens? We have Sequelize read the JavaScript code users, which is a table, .create, which is a method it gives us, this. It constructs some sort of SQL string in the Postgres dialect, insert into something, like what you were having to write with Twitter SQL for PG. It will create something like that. And it passes this SQL query to PG. And then PG, which is the protocol, will connect via the port and then use its Postgres protocol to tell PostgreSQL, the database, hey, this is a SQL incoming query, because we saw that it can only send SQL, whereas HTTP can send a lot of different things. It sends that SQL query after it told it, hey, I'm going to send it. And then now we're at the PostgreSQL dialect and database, like not PG Postgres node, but though they have the same picture, but PostgreSQL, the dialect in the database itself, which parses the query, talks to the file system itself, and then sends a response back. It gets a request, it sends a response, request-response cycle. It sends it back by the Postgres protocol, which is why we started the Sequelize connection with Postgres : // over the TCP connection that PG made. And then we're back in Node with PG, and it receives this raw string, which it already, we saw, converts it to an array for us. A row of objects, yeah. And you already witnessed these two things in action. And now the difference is it gives that to Sequelize. And Sequelize takes it and mutates that data into very powerful instances and classes, models, that have all of these prototypal methods and properties on them, like save and build and create and find and sync. That's what Sequelize does for us. So much good stuff. And it resolves a promise. If it's asynchronous talking to the database, those are promises like I showed you, the .sync, .create. Those are the only two we went into. .find, yeah. Those resolve the promise and return the create, because we did a create in this example, with the array of Sequelize instance objects. And so these are an array of Sequelize instance objects, which then have on them .save, .update, everything that Sequelize gives to them. So it's just an abstraction on top of PG, and it's going to let you code more in JavaScript. Now, you are going to build a Wikipedia clone, and the workshop will walk you through all the installing of Sequelize and everything that you need to get started. I mean, the workshops, I think, have been pretty helpful hand-holding. Any last questions? Okay, take a quick break.